to be implemented. How the symbol table is constructed. Okay. Now we need to know the basic idea behind what happens in the background whenever we are talking about a linker and loader. So linker basically, as we said, would be combining two different object files altogether to get a single output file, or you can say an executable. As well as it should get information about symbols to be followed for debugging purpose, or symbols to be used for debugging purpose. So let me show you what is the change rather. So I assume my terminal, okay, terminal is visible. Okay, so let me take a C code for a while to demonstrate you this. So let us say 6, 9, 21. Okay, so this is my code where I wish to make use of a call integer I equal to 23, integer j equal to 24, integer k equal to my max I comma j. Printf. I'm taking a simple code. Okay, maximum of %d and %d is %d I comma j comma k. Correct. So 06, 09, 21, 02 dot c. Integer max, integer a, integer b, if a, integer k, if a is greater than b, then k is equal to a, else k is equal to b, return k, and done. Fine. So let us say we have saved up these codes. Now let me write gcc 06, 09, 21, 01.c. Now we should get an error. The reason behind it could not find this. Correct. So if I try to generate this -c, an object code, we are not going to get any error for this. Definitely there are warning because we are making use of the functions. Okay, printf, it is not able to understand what exactly printf is, and my max prototype is not defined. Correct. So if I write nm or okay, nm 06, 09, 21, 01.0, you should see this my max defined as u. Okay, even printf defined as u, and again some table is there. Okay, global offset table probably. So some data structure is there. Fine. Now if I write this here, can I see some change? Definitely not. So if I don't write this and generate size, generate file, so 06, 09, 21, 01.0, see the size 1816. Similarly, if I go with my condition, and if I am adding this -g option for getting a debugging code, or the object code generated with debugging information. So what I do is I do fire this, and now we know exactly what is the size available. What was the size earlier without using -g was 1816. Now if I go again by adding this -g option, so let us see the size. Now the size became 3528. Earlier size was 1816. So it is nearly double to what we had earlier, correct? Right now we do have 3528. So if I try to compare this dash G always added say information, debugging information, dash G. Okay, whenever you use this dash G. Fine. Now when I created this, when I created an object code for this, I got an object code. So suppose if I try writing this ls-ltr. So I do see that there are two source files, but only one object code. Now I have to generate object code for my other file too. So let me write here 02C is correct. Now if I write, I do have object codes there. Now my linker comes into picture. So I write GCC 06092101.o 06092102.o, and then I am writing this dash G again. Okay. Now if I see what happened is I got an executable. Now this executable would be having some information. So if suppose if I don't add this dash G and if I try to see this ls-ltr, remember size was 18304. Now if I see the size, it remained as it is because there is no global involved. So that's why there was no any issue, rather no addition was done. So if I write nm 06092101.o, I will get this. If I write for 2, I will get this because this is found, my max found. Now when I combine both of them by generating this a dot out. So if I write a dot out, now I can see that my function, my max is defined as a part of text, but this printf still is undefined. What is the idea behind this, rather? Why it shows this? So let me show you particularly. My screen. Okay, let me know when it is visible. Is it visible? Yeah. Okay. Now see here. So we have command line arguments if are actually there. There would be object files given. So there may be many files. There would be some shared libraries. There would be some normal libraries. Okay. And when this is taken as an input, so linker control file. So while we work with GCC, okay, so it is working internally or making use of internally linker called LD, and that's why it is given to this linker. Okay, and then it generates executable file. If at all you add a dash G, then your debug symbol file also is created. Okay, which is not shown to us, which is actually dumped with your executable. Similarly, this link load map. Link load map is what? So when you say when you write a code, actually your code was generated in object format. Right now, when that would be mapped in memory, at what location that code will lie on, or at what location the code will load itself, that location would be decided. So that's why then the idea comes into front of us, like what exactly we mean by base address and actual address. Okay, like for example, if my code is starting at 0, okay, and my function call is at 10, and when it is mapped in memory, if my starting address is 100, then ultimately that 10 is to be added into 100, so that 110 would be the address now which I'm going to talk about a function call. That kind of mapping should be done with linking and loading kind of stuff. So that also is mandatory for us. So when we say this, ultimately we need to basically address that component through our code. Okay, like this. That's why, like right now it is not saying anything, but when you execute, okay, so if I write read lf dash sa dot out, so your symbols are occurring there. So here is your main, and try to see your my max. So this is my max, and there are a few other elements which are added, but it is some functions are kept undefined. Until and unless you execute the code, this would remain as undefined. So when you write execution here, actually your code got executed, and then this undefined changed to some address. We don't know. We cannot see that. Okay, if you want to see that, then you have to take dump at that time in background what is happening. So line by line, like when Java came into picture earlier. So suppose you are working on a UI. Okay, so suppose this kind of UI, there is an UI running, say for example, like this. Okay, Emacs is where? Okay, Emacs. Now suppose this UI is in front of you. Okay, now whenever you make any change, that change is reflected here. That means what? Code is executed here, but actually what is happening is everything is shown here. Say for example, let me show you that part too. Okay, suppose if I try to connect. So let me, okay, by the way, I'm showing you like how exactly it happens. Suppose I am giving some name, port host 127.0.0.1, username and password. So I'm giving AS. Okay. Maintenance DP, Postgres, AS. Okay. Let me do one change. Yeah, so you might have seen when I change the password. So if I say click on this, now what happens is you may see that I am doing some things here, but it is not repeated here. But what used to happen with Java, like you write code, you execute it, some things would be shown in the background here, like on the screen. Okay, so it is showing something. So if you do some changes in UI, ultimately changes, I mean to say, if you are working with some activity, if you are doing some activity, that would be shown here. So that kind of data needs to be captured in background. What is happening at that side? Right. So that care should be taken by us on that front to get or fetch that data, which I right now cannot show you directly on that front. Correct. With respect to this, what happened with this undefined thing when exactly it got changed to defined or some number like this, that would be taken care of it internally. So if you want to do that, yes, you also can do that by designing a particular form. Okay, or a particular application which could be possibly used on that front. Because if you recall, that day I gave you information about Microsoft's tool utilities, correct? Okay, the link that I shared on your our chat box of Microsoft team, like that can be used as a tool chain. But similarly, like if you want to implement similar kind of stuff with Linux, that also would be kind of great thinking in respect of the work that you may want to contribute with the system. Correct. So point here is like whatever you are making, whatever the changes that you are making on some side, that would be automatically taken care of. Now you might have seen like while I executed it, my password was something different. So that's why it was not getting connected. It gave me error. But when I changed that from here, suddenly it got connected. So these two things are definitely related, which is done by or through the linking happening in the background. Now, when we say linking is done in the background, what other things it is going to take care of? Okay, when I say other things to be taken care of, may not only involve your linker information, but also would have some more information in respect of how to capture this data from the respective file. Because on sorry, in the example that we took two different files there, correct? These were our files. This one was first, this one was second. Is my screen visible?
Yes, sir.
Yeah. So these two files we considered for example perspective. Now each one of them is having different symbols into it. Like for example, if I manipulate this code 060901.c, and if I add here integer k, okay, equal to say 12, some value I give. Okay, now suddenly suppose if I try to say compile my code 01.c-g. Okay, now if I check this in them 06091.o, you will see that that k is added there, which is kind of defined in data section. Correct? Because locals are not taken considered here. But then how I will know that what is local and what is global? Linker should know that. How exactly it came to know that this is global variable, that's why it added. So it must, our compilation process must have gone through some process which added that information into symbol table, where I found it was found in as a global constant. That's why it was added into data section. Now your other two variables I and j are not added here. They are not shown you here. Why? Because they are uh, getting rather into the stack, because local variables would be going into the stack. So let me create, yeah, this one. Okay, let me execute this. So simply say breakpoint main. Okay, and then you says they run. Now can I write pi? So it says, okay, your variable is found. Can I say pj? Can I say pk? Now you can see local variables are given value 0 because our code was having that information. I and j, we haven't reached to this location yet. Correct? We are at this bracket. So when I say step, now your instruction is I23. So if I display print I, there is nothing. But if I say again step, I already had a value. So if I try to display I, now I am getting 23. Correct? So this was fetched because when this assignment got executed, it came to know prior executing this that there is a variable I, because if you recall the diagram that I showed you before a while, the debugging information is always added. See this diagram, the debug symbol file is always added. How it came to know? Now this I actually is not I there. Why it is not showing anything there? So if I try to say xi, it says boss you cannot access. This examine with the address represented by I. But I can simply print it. Like if I try writing display I, it also shows me. But when I'm trying to examine, so contents are that memory address. I really am not sure what is the exact address. So this I and J might be replaced. So let me show you the object code. So let us give simple values which easily can be translated into hex. So we'll take here 10 and 20. So 0A and 14 would be the values. Okay, let us remember this. This is 0A and this is 14. So 20 in hex would be 14. Fine. So let us save this. Control X, Control XC. Generate object code. Okay. Generate executable. So if I see obj dump dash d, let us see first object code of our first file. Pipe less. Now let us see main here. So it is showing RBP. So let me get this to 32-bit code because we worked with 32-bit code. That's why. So registers should be known to us. Yeah, so let us go to main. Yeah, this is main. So if you recall, I said 0A and 14. Can you see this? Now it used EBP. Now this is a base pointer for the temporary stack created for main function. Okay, because what happens is like when you debug, we can see this. Now when debugging starts, okay, you say breakpoint main. Now, as I said, or you might be knowing this, like whenever a function gets executed, if you recall, I talked about prologue and epilogue. Can you recall that part? Can you record these words, prologue and epilogue? Prologue would be the one which would be created as an environment for a function call to get executed. And epilogue would be clearing that part. So if I write BT, okay, this BT means backtrace. So it says no stack. So when I execute, if I write BT, now as function got executed as main, it is showing us that there is hash 0, which is main. So this is stack number 1. Correct. So if I display, say, for example, base pointer and stack pointer. These are the values. Now there is no function call. That's why only one stack is there, which is ES with ESP. Okay, so let us say step. Now see the code. When exactly code execution started, your EBP changed. Now it is in the stack. Okay, so it was C0, then we got D8. So 4 bytes are given and some number of bytes are given. How come the address was given to it? That is not our role right now, because from C0 to D8, whatever the data is, it is used internally by the system. If I try to see the difference between them, both of them, let me say step. Now these values will never change right now because the local values are stored somewhere here. So if I try to say display, say for example, examine $ESP -4. So let us display it. So -8. So they are having addresses, correct? So let us say +4, +8. Now you will see like what was the first value gave? We gave this I equal to 10. That's why this value is stored here. So if I write ESP +12, then it should show 20. Okay, why it is not showing that? Okay, let us go to 16. The reason behind we haven't executed this statement yet. Correct? So if I say step and if I write ESP +12, then see now what happens. It is showing us 20. That means what? The local variables are stored into the stack. I proved it right now to you people, correct?
Hello, sir.
Yes.
We were not able to see your terminal screen.
No,
Only image is there.
I thought you could see right now. Check.
Yes, sir. Now fine.
Okay, let me start one more time. So what I did was earlier from since when you are not able to see this?
No, sir. Now fine.
Okay, so I am generating M32 instruction because the code was M64, 64-bit instructions. Now I want it to be a 32-bit code. Yeah. So say I got both of the code in 32-bit. So say I got both of them. 2 also I got. Now let me link together with 32. Now when I say gdb /a.out. Now we know that like if I try to say breakpoint main, if I write bt there, it says there is no stack involved, correct? If I say run, now my code started. If I write bt, there is nothing. Now we know that like if I try to display, this is a stack because we are executing this main. Okay, now if I want to display %EBP, sorry, not percent, dollar. EBP. So there is nothing involved there. ESP, there is nothing involved. So we are now starting execution. So if I say step, now you can see both the addresses got affected because prior executing this bracket, it was having earlier addresses. Now the stack got created. So we got these new addresses for ESP and EBP. Fine. So if I write BT, I can see that there is only one stack because we are executing main. Now we said that K variable K, which was added by us, is a global variable, correct? So I would be able to see this 12 definitely somewhere with my stack. Display, oh sorry, let us print, let us examine slash D $ESP plus 4, ESP plus 8, ESP plus 12. Okay, so now let us go with minus 12, minus 8, minus 4. Okay, so let us go beyond 16 as well. Okay, 20 minus 20, 24 plus 24. So right now we don't have information about that where exactly K is. Okay, but now we are trying to trace with this I and J. Now what are the values for I and J? 10 and 20. Why we took them as 10 and 20? Because we know exactly if I translate them to hex or convert them to hex, what would be the representation? The representation would be what? A and 14 hex. Okay, so let us start the execution. So run step. So we have addresses. Okay, now first value is assigned. So if I try to examine now x slash d $ESP minus say 12. Okay, so if I say 8, if I say 4, so I'm not able to get either of them, correct? So ESP even I'm getting 1. Correct. Now let me execute this step again. So I'm executing this statement now. Okay, let me execute this. So it got executed. Now let me check the values again. What are the values that I tested? 12, 8, 4. So let me go with 16. So negative is not working. So let me go with now plus 12 plus 16 plus 8. Yes, I got ESP plus 8 where my local variable is, which is stored as decimal. So I am showing here decimal. So if I remove this x slash d and if I write this, then it shows me 10 even at that address with by default to be decimal. So if I write here x slash x, then it shows me a. Fine. Similarly, let us go execute the next statement as integer j equal to 20. So as it was found at ESP plus 8, so ESP plus 12 right now is not having anything. So let me display this in decimal. Is not having any number. So if I say step and if I now check this, I can see that my stack got affected with 20 because I am picking the value from the stack. Correct? So now let me execute this call. Now if I try saying this BT, we are having only one stack. Correct? Now remember that at ESP plus 8 and ESP plus 12, we had both the values. Correct? Let me show you this ESP plus 12 and ESP plus 8. We have both the values. Now we are having next line as k equal to my x. Right now currently we have only one stack. So if I say step, now it started executing into my max. You can see here. So if I write BT now, you will see that second stack got created. Correct. Now if I try to verify these values, I do see that 10 and 20 is still there, correct? Let us check. Sorry, plus 8 plus 12. So I got this 20. Okay, for 8. What about my 10? So if I write 4, I have to this one, correct? Now I'm jumping into code of this my max here. Correct. So if I say step, And now you will see my stack addresses got affected. This was earlier stack address. Now these are the addresses. They got changed, correct? If I write now this, I'm not able to see my values because that scope is lost. Right now, my scope is with this code of my max. That's why a stack is created here. Sorry. That's why it is showing that, OK, you are into this stack now. You are using this stack. And the values are reflected there with A and B because those are the values which are passed through the stack. OK, how it came to know that A and B through the stack it was passed whenever you call a function. Okay, if you recall in assembly, we wrote a code to print something. So we said push message and we said call printf. So printf should take that MSG as a variable to display as a value for. Correct? That's what we saw. Similarly, whenever you are using any function, all your parameters would be passed through the stack. Fine. So now my scope was lost. Now my prolog and epilogue is different now. Correct. So let me execute this. So let me go to if a greater than b. Let me go here step. Let me say now if I see bt currently there are two stacks. Fine. Even see the addresses. They are not getting affected because we're not calling any other function. So step. Now I am coming back to my original code. Correct, from after this line. So step. So I got now my original addresses. They are not A8 and 98. Now they are D8 and C0. So if I write BT, earlier my max stack got deleted. And this information is added through the code that already through the information which is given through the libraries. OK, so which are those libraries? So let me show you. These are the libraries. OK, shared libraries, normal libraries. The information would be shown and given this link load map would be kind of thing that is generated as an outcome perspective. So your all object files, two object files were taken together. There were no command line arguments, but there were some information passed to it, linker control files, which could help us in getting this stack with what we were talking about. Generating the stack. OK, so and then as an output perspective, what linker gives when you started executing your file, you were knowing what is the debugging symbol, where exactly I can find my stacks through this link load map and my executable file. This would be output from my linker perspective. Fine. Any question till this? Okay. Anyway, I will be showing you like what happens when you come out of main. Okay. Now we were in main into main function, correct? We were into main function. Yeah. We were into main function. So if I write BT, we know that we are here. So we are going to execute this statement. OK, right now, which is currently under execution. So if I say step, now check, we are not reached to endpoint. So that's why curly bracket still is there. These values are protected D8 and C0. Even if I write BT, there is only one stack. So when I say step, we are coming out of main now. We came out of it. Suddenly, with what we started, EBP to be 0 and D1 F0. So let us see where exactly it is. So we had 0, 0 and this one. This was the stack created. That's why ESP had something for main because code got executed. Correct. That's why that main was so that's why this value got changed. But when it comes out of it after execution of main, when main is deleted from memory, this EBP remains at 0, becomes 0 because there is no stack. So this EBP is used for a routine called frame dummy. That frame dummy is a mechanism which creates a file, which creates a stack for your function called support. And where return address and everything would be stored. ESP you cannot directly use. That's why this base pointer EBP was given into the Intel architecture. And like every linker would be making use of some similar kind of help. it is going to take help of your architecture only by making use of these addresses. So if I write BT, you will see that main is gone. Whatever the stack for main was there, it is not seen now. Correct? We can see that there are two other stacks. One is libc and other one is underscore stop. So if I say step, so it terminated the code. So if I write BT, it says nothing. I don't have anything to display to you right now. Understood this? Any question? Okay, now what exactly it did, if at all we say connecting information about or combining information about both the variables. Okay, so let me show you that part too. You can ask if you have any questions, by the way. I'm not able to hear you. Can you write your query into chat window, because audio is breaking a lot. So let me open the terminal to show you. Yeah, somebody was asking a question. Okay, now if you see this, what exactly this linker did for you? You had object code A, okay, or function A, which calls BCD functions. Okay, object B contains calls to C and E. And suppose in library 1 CDXY is there and library 2 EF is there. So these two codes, when they link together, these would be the libraries from which the functions would be called. And your executable file will contains all these calls all together like this. A, B, C, D, E. Correct? So A and B would be from your original code, and C, D, E would be linked from your respective libraries. And that's what happened. Like when we saw NM output for our symbols, okay, at runtime. So where exactly here? So if I quit this, if I say NM 060921.0.0, I can see that there are these things added. Okay, I never use thunk or I never use this whatever exactly. I could see that in my code it only contains these four. Similarly for 2, I do see that this is my name. This is not added by me. So these definitely are picked from some library functions. And like when I generate or when I see this a dot out, when I see my a dot out, at that time it shows rather this thunk. Okay, like for example, if I go above and see for first file, what was the thunk? AX, another thunk was BX. Can you see this? This was AX and this was BX, correct, from the respective files. So both of them are added there. Right now they are part of text. Okay, that means something is done internally, and that's why this AX and BX is added. But similarly, there is something added by it, BP and DX, even registered TM clones, start, then libc, CSU, FINI, init, main, everything got added there, which is not written by me exactly. I gave call to main, I gave call to printf, so printf was shown here like this, for example. But again, it doesn't have any information about printf because it is to be picked from this libc. That's why you will see that library name is attached with it. And these are some data structures probably which might be used internally here to add into information about symbol table. So even suppose if I try to display my symbol table by writing this, I can see like this is a symbol table. And where my entries are somewhere below. I can see main, I can see K, then my function was containing printf call as well, correct? So let us see. I can see printf. Yes. Now let us see my max. Yes, I can see my max. These are the things which I used in my code, but rest of the things are added through the library. That's why, like, what are the picture that I showed you before? It creates a kind of impact in front of us, like how exactly it would be picked and your executable file will be added. So let us think of a code now. Let us say if I give you two different files. Okay. Suppose object A contains calls to BCD and object B contains call to CE. And this BCD and CE are not part somewhere here. They are a part of library. So I want you to think of now. Let us say we don't have library things. This library might be called something say capital F, and that capital F contains this C, D, E definitions. So it should be linked together like A, B and C, D, E should be picked and it should be shown in a single symbol table. So if I have two different symbol tables, if you write a code which can generate a symbol table for your code with assumption that you already implemented a code for generating a symbol table, no matter whether you are working with one pass assembler or two pass assembler. So can you come up with the code which would be linking two different object codes and will give you something what we call as a combined symbol table? Understood the idea? What I am trying to tell? Yes.
Yes, sir.
Okay. Okay. So this would be an important thing for you people to understand how exactly it is going to pick from the library. Okay. So when I say how, ultimately, like if you recall in the previous session, I showed you like we have to make use of -lm to link the library, external library, right? Which is a math library. So similarly, some libraries would be picked always, no matter how exactly you go with, correct? How exactly you go with, fine. Oh, let me go to now how, like if at all you are expected to do this thing, how do you think you should move further to get everything done? How will you implement this? What do you think? What would be the problems? Like suppose let me pick two people from your batch. Okay, suppose Shivdip wrote some code. Okay, and like his code and Sneha's code is to be combined together. Do you think there would not be any issue while combining both the codes together? In that case, we need to know whether have they used similar architecture to write the code. They may be sharing the same code, like they might be part of a team where they are contributing as a team member. But how we will know that they are using the same architecture which is to be used or followed? So if architectures are different, it would be difficult to combine the code together. So what happens is like we require like the way that we say API terminology. What is API? You must have heard about, na? What is API? Have you heard API? Application Programming Interface. API. Like whenever you are working with Java or even .NET, you are going to give calls to some functions which are available as API calls. Similarly, whenever we are dealing with architecture level, every operating system will be having its own application binary interface called as ABI. So let me add into chat window first. API is what? Application Programming Interface. application. Okay, and there is something called as ABI, application binary interface, and every operating system will have that. And what that ABI consists? ABI consists of different conventions of programming which the applications must follow so that they can run in the operating system. Like for example, if you create an executable, will you be able to execute that executable onto your mobile phone? Probably no, because the architecture available on your mobile phone than architecture you are having on the laptop or desktop that you are using to generate the code is different. So you have to generate the code so that which can run on the hardware available at that other party or other side. So we have to write code actually appropriately that way. Now what this ABI contains? ABI contains different system calls. Now what is system call? System call would be the mechanism by which you are going to communicate with your operating system. Correct? By which you are going to communicate with your operating system, and it definitely would be telling you what would be the method to call the system calls. Like for example, if you recall, okay, you might not have seen rather. So let me show you some stuff. 1 minute. Yeah. Okay, so let me show you one code available on my machine. Okay, which I use to demonstrate to the operating system course students rather. Okay, from MCA. So this is my code. Now I am making use of a system called fork. Now this fork, if I see, is used to create a process or to create a child process. Now how can we use it? Like it is to be used like this. So I will add this code for your information too. So I do give call like this. So which returns a process ID. Now let me execute this. So I'm opening another terminal for your information. Okay, so that I can show you like what is happening at that side. So let us generate GCC. So let us say ps-ejh pipe less. So you can see that we have bash. This is PTH0. Now this current terminal is PTH0 and the terminal that I'm using is PTS1. Fine. Now see that I'm compiling this code and generating an executable from it. Okay. Now if I see here again, I will see PTS0 and PTS1 altogether the way I saw earlier. Correct? PTS0 and PTS1 with less. So these are the only, like as we are using these two terminals, this one and this one, it is showing us this way. Fine. Now if I try to execute this code from here, what are the a.out generated? Now it printed this twice. Remember what are the numbers? 9767, 9768. So this first column tells us process ID. Now if I fire this again, now let us see how many a.outs would be. Can you see two processes added? A.out, A.out. Their numbers are 9767 and 9768. See these both. Okay, because this was our parent. In parent, we gave call to fork in the code. That's why it executed that code twice. And it is showing us hello displayed twice. Okay, but first hello was displayed from 9767 and second hello was displayed from 9768. Correct? And this is what I wanted to tell. How exactly this data is transferred? What are the ABIs? Those are there. Application binary interface, which is added there. It would be telling you how to make use of this system call. So we gave call, it executed the body of fork, and we can see output of this. So we can see that same code was executed twice and both the codes are in memory. So suppose if I press enter, or suppose I'm giving one character G. Now let me see what happened here. So okay, let me quit from here. Let me go below. Now can you see 9767 here? No, 9767 is not there, but 9768 is still there, which was a child. So parent gone. So now if that means what? It is waiting. Is it waiting for my cat command or some command from Linux, or it is waiting for the getchar that I added there in the second code? So if I press like key, now you may say that I'm telling you, have belief on me. So suppose believe me. So I'm pressing H. Now that H is not displayed, you may see that it got stuck. Can you see the thing? Cursor got stuck. Now if I see and execute this code again, this ps-cjh, that 1768 is not found. Sorry, 9768 is not found. That was gone. So now if I start pressing a character, now it will be reading my character. Correct. So this ABI actually helped the code to execute at that level. Correct? Execute at that level. So that's why this ABI clearly plays an important role. So what I will do is, for your information, I will add this file. Okay, so that you can try this on your laptop too. Code was 12.7. It was 12.07. So okay, so this is a code that I have added for you people. So you can try executing this and see what happens there and how the system call got executed. Okay. So like, I think I should stop here. So we'll continue in tomorrow's session. So if you have any query, you can let me know right now, or you definitely can update me accordingly. So either through the personal window or say a message in the group.